Hello everyone, we are from Group 3 will present audio model. First, we all have to know what is data model. Data model is a formalism that helps specify the aspect of data relevant for their organization. And we also have to know what is traditional data modeling. Traditional data modeling is a media object can be treated at multiple levels of abstraction. Now we will briefly explain about the multimedia query languages. There are some multimedia query languages such as Video SQL, QBIC, Score, Virage, Visual Seek, and SEMCOP. Video SQL is the earliest query languages for accessing video data. It has certain limitations. It also provides select clause, where clause, and from clause. QBIC allows for querying of images and videos. With QBIC also, the images are queried based on scene or objects, and video are stored in terms of their coherent contiguous frame sequences.
Next is Score. Score is similarity-based image retrieval system uses a refined entity relationship model to represent the contents of images, which is the similarity between queries and images in database. It doesn't support direct image matching but provides interface that enable visual query construction. Next is Virage. Virage is the earliest commercial image retrieval system, where it is mainly based on visual. It is the formulate keyword-based queries but mainly at the whole image level. It is also provides an SQL-like query language. We go to the next language. The next language is Visual Seek. Visual Seek is mainly relies on color information to retrieve images. It provides region-based. The image retrieval, even though it is not directly object-based, it also provides mechanism for image and sketch comparison. Lastly is VCSQL or SEMCOP. What is VCSQL? VCSQL is the model's images and videos as compound objects, each containing a hierarchy of sub-objects. Audio data are often viewed as 1D continuous or discrete signals. In that sense, many of the feature models, such as histogram or DCT, applicable to 2D images have their counterparts for audio data as well. Unlike images, however, audio can also have domain-specific features that one can leverage for indexing, classification, and retrieval. For example, a music audio object can be modeled based on its pitch, chroma, loudness, rhythm, beat or tempo, and timbre features. Pitch represents the perceived fundamental frequency of the audio data, whereas frequency can be analyzed and modeled using frequency analysis of the audio data. Perceived frequency requires psychophysical adjustment. For frequencies lower than about 1 kHz, the human ear hears tone with a linear scale, whereas for frequency higher than this, it hears in a logarithmic scale. Mel scale is a perceptual scale of pitches that adjusts for this. Bar scale is a similar perceptual scale which transforms the audible frequency range from 20 Hz to 15,500 Hz into 24 scales. Most audio feature analysis is performed in Mel or bar scale rather than original frequency scale. Next is chroma. What is chroma? Chroma represents how a pitch is perceived analogous to color for light. Pitch perception is periodic. Two pitches P1 and P2, where P1 and P2 is equal to 2 to the power of C for some integers C are perceived as having a similar quality or chroma.
Next, we will explain about loudness. Loudness is a subjective measure, is often confused with objective measures of sound strength, such as sound pressure level, sound intensity, or sound power. Loudness is affected by parameters other than sound pressure, including frequency, bandwidth, and duration. Loudness has two psychophysical measures, which are phon and zone. Zone is a unit of perceived loudness proposed by Stanley Smith Stevens in 1936, and phon is a unit of loudness level for pure tones. That purpose is to compensate for the effect of frequency on the perceived loudness of tones. Beat is a regularly occurring pattern of rhythmic stress in music, and tempo is a speed of the beat, usually expressed in beats per minute or BPM. Next, we will talk about rhythm. Rhythm is a repeated patterns in audio. It is related to the periodicity of the audio, and it is more complex measure than pitch and tempo. It has a feature that named as rhythmogram. The rhythmogram will detect the onsets based on the spectral flux of the audio signal, which measures how quickly the power spectrum of the signal changes. And lastly, we will talk about timbre. Timbre represents all characteristics of an audio signal except for pitch and loudness. Timbre also has a tone color or tone quality from psychoacoustics, the quality of musical note or sound or tone that distinguishes different types of sound production, such as voices and musical instruments, string instruments, wind instruments, and percussion instruments.